So this is example 2. Okay, now for this one. This one says, assume that the probability of a defective Firestone tire is 0.0003. So it's really what? 3 10,000ths. If the retail outlet car stuff buys 100 defective tires, find the probability that they get at least one that is defective. So what this means is we need to find the probability where at least one tire is defective. And I'm at an angle, so my writing's going to be a little bit off at this point, you guys. Okay. And like I said, all these other slides, they follow the setup for it. What I'm going to do is I'm going to write all the steps and denotations on this one, and then we'll go through and see if they're right. Okay. So for this one, what I suggest we start off with is let's actually label some of the numbers we have in here. Okay. So it says a tire is defective and it has a probability of 0.003. So I'm going to write that here somewhere. I'm going to write the probability of a tire, and I'll put defective tire. Let's do that. It is equal to 0.0003. Now that was from the problem itself here. And then it looks like we're going to be looking at a sample of 100 tires for this scenario. Okay. So I don't really need the 100 just yet. That's just to signify my sample space. So let's actually get to this. And remember, the main keyword here is that at least. Okay. So for these problems, you will not encounter a question saying at least 4, at least 5. Okay, this is specifically tackling the at least one scenario and nothing more. So because of that, at least I'm going to actually go through and just label everything for that procedure I had with step 1. So I'm going to do step 1. And step 1 is just basically, what am I looking for? Well, I want the probability of where I have at least one defective tire. Okay, and that is actually my event, which I'm going to call A from here. So rather than just, I'm going to copy this right here. I'm going to actually bring it down with this one. I'm going to say for step 1, label the event. Which we've already done is basically the main question at hand. Well, step 2 basically have us list the opposite of that. So step 2 is we're going to basically write the opposite case that we are looking for. So remember, every time that you see that at least one, and my handwriting might be a little bit ugly at this angle, so if I have at least one, you write it as the word or statement of none. So the complement, rather than getting at least one defective, I don't want to get any. So I don't want no defective tires. So I want none, which might also translate to be like no defective tires. Now, before we begin, that seems kind of awfully word in the word sense. So what does it mean if you have no defective tires? Well, that has to translate into all non-defective tires, which means they are all good tires. So we have all non-defective, which just means your tires are good. It's a little bit over. Okay. So that's really what we're looking for. We don't want none of them. We just want to get the good tires now. So we want all good tires. Okay. So that is our step 2. Let's look at step 3 now. So step 3 says now we find the probability of whatever that complement or the opposite was. And we said ours were all good tires. So we need to find the probability of getting all good tires here. So I'm going to write it once again down here. We want all good tires. Okay. Now, when it says all, the all really came from the sample that they were asking for. So in this case, all implies that they're looking for 100 good tires then. So keep that in mind. That is what your small little sample space is for. It is for getting that total amount with them. So we are really looking for 100 good tires for this specific scenario. So let's find that now. For this case here, the 100 just means I would essentially have 100 blanks. I would repeat this for 100 total, and then I would have to find the probability of getting a good tire. So if I want a good tire, before we look at all 100 cases, let's look at just getting one good tire. So what is the probability of getting a good tire? Because that was not stated in the problem. Because what we have in the problem was we have a 0.0003 probably getting a defective tire. Well, all I have is a defective one. So if I want to find the good ones, I'm going to take a complement in here. So, and this is where I said the wording gets tricky. You have to go back to see what you have from your problem. So for this one, I'm going to denote this here in like red. We were told from the problem a defective tire, but what it's asked, when I did the complement with here, or the complement for this problem, I need to find the good tires in this. So if I need to find the probability of getting a good tire, and I'm doing this a little bit, I'm gonna put it down here. If I want the probability of getting a good tire, it is really 1 minus the probability of a defective tire, which we know the defective tire was 0.0003. So I have to subtract that probability from 1. And if I subtract it from 1, I would end up with a 0.9997. So that right there is the probability of getting the good tire, which I'm going to put this up on the very, very top. And I'm going to use my mouse to actually make this a bit smaller for us. So that's our extra bit of information that we get from here. Okay. So I do have the probability. It was not stated from the problem, but I'm still capable of finding it. So what that means is this number, it's going to be the probability of getting one good tire when I perform this calculation here. So remember, go back to the black ink. The probability of 100 tires, or 100 good tires, I would have 100 blanks. And I would multiply this by the probability. Now I can't really fit this on here, but this would go in this spot, and this spot. And I don't have to put this in the calculator. That's going to be quite tedious. So if you have 100 samples you're looking for, you can write this as the probability raised to 100. And whatever that value is, you will end up with a very large number. And I do not have a calculator with me. Let me open up one of mine real quick. Whoops, there we go. So I have to put it with the parentheses. I have this 0.9997 raised caret to 100. There we go. So it is a large number. We end up with a value of, whoops, a second, get it before, 0.9704. I'm going to go just to 4 decimal places. So 0.9704. And that value is the probability of getting the 100 good tires. Okay. Now remember, this is not my final answer. Our original problem or question said we want at least 1 tire is defective here. So in order for us to find that, we have to take the complement of this. So our final step is we are going to take another complement. It's going to be the 1 minus the probability we found in step 3, which was the 100 good tires. So this is really 1 minus 0.9704, which if I do that in the calculator, it'd be 1 minus 0.9704. Our answer is 0.0296. So that is the probability of having at least 1 defective tire.